So in this video, I'm hoping to show how to set up GeoServer. There's probably more efficient ways to do this to get local map data into Cesium, and I'll show what these applications are here in a second. I have the page up for GeoServer. This is what's going to hopefully host our map data that locally on DragonOS so that we can send map um, map files, basically, well, make them viewable in both PhotonMap, which is an application in DragonOS, but probably more so in DF-Aggregator, which works with the KrakenSDR. So essentially being able to do direction finding offline with map data that you have locally without the need of an internet connection. So that's the goal anyways. I'll see if I can duplicate this here. So to get started, we're just going to download the GeoServer 2.21, and I'm just going with the platform independent binary to make this simple for this demonstration. Jumps over to SourceForge and should download. Of course, with the advertisements here. Alright, so we have that. We're going to close that. We're going to go to downloads, unzip the GeoServer. Ideally, I probably should have put that in its own directory to keep this a little more organized, but we'll just go with this for now. What we need to do is enable cores, and if you've watched my videos on or in the past with PhotonMap and Kismet, you'll see what that is and why we need to do this. But to do this with the GeoServer, I wrote down some notes here so I didn't forget. Web apps, GeoServer, WebINF, and we'll edit the XML file here. We need to go down and we need to find, let's see, probably passed it. Okay, so uncomment following filter to enable cores. We need to do this one. You could do it a couple different ways. I'll just leave that comment there and delete this off at the end. Come up a little bit more, and we are not running, we don't want to do the cores in Tomcat. We want to go up a little higher, and we'll do the Jetty. Let's see. Okay, we'll Control O, enter, Control X if you're using Nano. And let's see, we're going to go into the bin directory. Come back up a few directories. Alright, so we're back in our downloads directory. We'll go into bin. And I don't think we need to do sudo. We'll just do a startup. That should bring the GeoServer online. I can see localhost or 0000 and sorry, 8080 GeoServer. Default login is admin and GeoServer. So we have our GeoServer up and running. It already has some layers, stores, and workspaces. I'm mainly concerned with this web map service, which I've got working here. If we look at layer preview, we can see we've got a couple different layers here, like this poly landmarks. Can open it up. You can see I'm interacting with the GeoServer. Map is displayed. Okay, so we've got cores enabled. We've got the map server going. Now I'll show the changes that I made to the user source PhotonMap HTML. In that directory there's an index.html, and I've talked about PhotonMap before. I come down, you're going to see a section after the where it's talking about Kismet, and there's a var viewer, and initially it had the new Cesium viewer, it had the scene mode picker, home button, timeline, uncommented. I'm just messing around with this right now, but essentially we've just kept everything as is, commenting out the middle area. I've got a new statement in here, add a WMS imagery layer, and this is what I've been messing around with and trying to learn more about and getting tweaked to where it actually worked. So I added WMS imagery layer. I define this imagery layers equals viewer.imageryLayers. Key part is the Cesium Web Map Service Imagery Provider, and you can see how I've put the URL, which matches up here, 8080 GeoServer WMS. I've got my parameters. There's more parameters. I'm still like learning about that. And then layers. You can see that layers matches up with the name here, the tiger poly landmarks. I commented out the maximum level, and everything else is pretty much the same in PhotonMap. I didn't touch anything else. So if we exit out of that and we do a Python 3-m http.server, and we bring our PhotonMap, put that little closing bracket there. Okay, we can pick a map layer, say natural earth. Now, let's see. We can see that we're getting some interaction here. And if we scroll way down, we can see that we have our WMS imagery being overlaid onto the map. Now, of course, this other map data is coming in from the internet, but the goal is to get this map data all replaced to where it can be offline. Okay, so we see we can do that. So let's try and take a TIFF file, and we're going to load that into GeoServer and see if we can get that to display. To do that, I'm over here on naturalearthdata.com. I'm going to download the natural earth with shaded relief and water. Let's try and move this into map data. Okay, and we get yet another folder, so that's fine. Take a look in there. Okay, we've got our .tiff file. Okay, let's come back here. We'll make a new workspace. Take a look at some of these other ones. Okay, so we'll make a new workspace, and let's see. let's make a store. Let's see. Make a store, and we need GeoTIFF. Okay, we'll put it in the YouTube demo. And what are we going to call this? Okay. Oh, need to actually find the file. So it defaulted to data directory. I guess we could have put it there, but let's see. Home, downloads, map data. Let's get the TIFF file. Let's see if we can save. We'll save. We'll publish that. I'll leave everything pretty much default here. Yep. Save that. Alright, so we see manage layers being published by GeoServer. Here we got our layer. Now let's try this out. We'll stop PhotonMap. Let's sudo nano index. Let's come back down, and we'll see if we can just change this layer that it's referencing. Maybe we don't have to saving geo. Okay, saving. Let's restart this. Actually, no, that is far more detailed than the natural Earth too. So it looks like it's overlaying right on top. Let's see. Yeah, okay. So it's right over top, and you can see the it's pulling it from the map server. Yep. Yeah. Okay. To show a little bit more. So there we go. Okay, so we have essentially taken that map data and overlaid it over top of Cesium here. Interesting. Okay. All right. So let's see if we can apply this same thing to DF-Aggregator. So DF-Aggregator, a little different. We need to go into views, and in this case we're going to do sudo nano cesium.tpl, but you're going to see it looks fairly similar. Alright, so I'm going to focus on this area here. Set default map. Okay. Imagery provider. Let's just go ahead, comment this out. Scene picker. Map projection. Leave that there for a second. Let's see. So I'll take what we got over here, what we added. Which is right here, and we will try to put it in here. Alright, and So this is DF-Aggregator. We'll Control O, Control X. Let me think. So we'll stop, close out of PhotonMap for now. And so let's see, so we have GeoServer on 8080. So we need to remember that, because I think, let's see, this defaults to 8080, so we're going to change that port. So let's see, we'll do DF-Aggregator. We need to specify a database file. I'll just stick that in home dragon test. Yeah, test is fine. We'll go offline and we'll change -- port equals 8081. Or actually 8000 is fine, because we're not using PhotonMap. So let's see what happens here. Okay, so DF-Aggregator. Let's see if we get the same thing here. So we've got GeoServer in the back here. Okay, I see it's pulling stuff. And let's zoom in. There we go. So we are using that new layer from the GeoServer. Now what you'd want to do is get an area where you're going to be doing your direction finding, and get the map data obviously in the right format into GeoServer. And then for right now, till I figure out a little more, maybe I'll make that a second part. Maybe we could make a way to add that map data, or turn it on and off different layers like you're doing here. So at least you should be able to, without internet, this menu would still pop up. I imagine you click on Natural Earth 2 or anything to get the globe to appear. You're going to be running with the map data that you have coming from the GeoServer. Alright, so hopefully that answers some questions. I had some people asking that. I guess this would also come in handy too when you're doing, in the last video I just did, you're doing your RF propagation, and you want to display that KMZ, KML that came out of the signal server GUI. You could use PhotonMap, which has that ability to upload the KMZ, KML file to display, and now you have your map data, and there you go. All right there with DragonOS. Alright, thanks.